Hello friends, welcome back to a new video of I Square. In the previous classes we have learned how to solve a pair of linear equations graphically, and in some cases it took a lot of time to solve them graphically, and also it is difficult if the solution is some fractions like 1 by 19, 2 by 23. If this is the solution or if this is the point to be plotted in the graph, it is difficult for us to plot these points in the graph. For example, let another point be 0.33 and 0.444. It is difficult for us to plot these types of points in the graph. So graphical method is always time consuming rather than algebraic methods. So in today's class we are going to give you the algebraic method to solve a pair of linear equations in two variables, and we have many methods to solve a pair of linear equations algebraically, but in today's class we are going to discuss the important and efficient method for solving a pair of linear equations in two variables, that is substitution method. This is the method we are going to discuss in today's class. So let's move on to the method. Now, from the name of the method itself, it's clear that we are doing some substitutions in this method. Now, let me explain this method using an example. And the example I have taken here is this pair of linear equations, that is x plus y is equal to 14, which is my equation number 1, and x minus y is equal to 4, which is my equation number 2. Rather than solving this graphically, today I am going to solve this equation algebraically in the method of substitution. For that, the first step I am going to do is I am going to take any of the equations from these two equations. For my sake, I am going to take x plus y is equal to 14. That is my first equation here. That is x plus y equal to 14. Now I am going to find any variable from this equation. Let it be x or y. It's our sake. Now for my sake I am going to find the value of x from here. Therefore x is equal to 14 minus y. I found the value of x in terms of y. Now I am going to name this equation as capital A. Now let it be here. Now I am going to consider equation number 2. I am going to consider equation number 2. That is, consider equation number 2, and I am going to substitute equation A in equation 2. I am going to substitute this value of x in equation number 2. So considering equation number 2, we have equation number 2 is like this: x minus y is equal to 4. And in this equation, I am going to substitute the equation number A, that is x is equal to 14 minus y. In this equation, in the place of x, I am going to substitute this value, that is 14 minus y. So instead of x, I am going to substitute this 14 minus y, and again minus y from here, and equals to 4 again from here. Now this equation has become an equation in one variable, that is an equation in y. Now let me solve this. 14 minus y is minus 2y equals to 4. Now solving this linear equation in one variable, it is easy for us. That is 2y equals to 14 minus 4, that is 10. Now y becomes 10 by 2, that's 5. So we got the value of 5. Now it is easy for us to find the value of x. Since we got the value of y, that is 5, it is easy for us to substitute that value 5 in here. Now let's substitute y equals to 5 in equation number A. That is, x is equal to 14 minus y. That is, x is equal to 14 minus y is nothing but 5. Therefore 14 minus 5 is, we have, it's 9. Now x is equal to 9. Yes, we got the solution. Y is equal to 5 and x is equal to 9. So our solution is 9, 5 corresponding to xy. This is our solution, 9, 5. That is x is equal to 9 and y is equal to 5. Let's go for the verification. Considering equation number 1, x is equal to 9 and y is equal to 5, and 9 plus 5 is 14. So starting from LHS we got RHS, that is 14. Now coming to equation number 2, LHS is x minus y, that is 9 minus 5, that is 4, which is our RHS here. So the verification part is also completed. So this is the method. Let me explain once more. First of all, we have two equations. Consider any of the equation from them and write it down like that. Now, and from that equation, we have to find any one of the variable in terms of the other. Here, I have taken x in terms of y. Now, put that equation aside and consider the second equation. And in second equation, we are going to substitute the equation A, that is, we got the value of y from that after solving that equation. After getting the value of one variable, we are going to substitute that value and that value here so that we get the other variable also. So we got x and y. So that's the solution for the pair of linear equations, and then we go for the verification part. And that's it. This we have twice substituted the values in this substitution method. That's why the method is called a substitution method. Let me do one more example so that the method is that much clear for you. Now the next example is s minus t is equal to 3 and s by 3 plus t by 2 equals to 6. Here the two variables are s and t, and here is the pair of linear equations in two variables. We are going to solve this pair of linear equation by substitution method. For that, the first step is from any of these equations find any variable in terms of the other variable. Let me consider this equation, and from this first equation I am going to find out the value of s. Now the first equation is nothing but it is s minus t equals to 3, and from that I am going to find the value of s, that is 3 plus t, and I am going to name this as equation number A. Now let's put it apart, and now we are going to substitute this A into the second equation. That's our second step. Now substituting A in equation 2. Okay, now let's write equation 2 first, that is s by 3 plus t by 2 equals to 6. Now instead of s, we are going to substitute this 3 plus t. That is 3 plus t divided by 3 plus t by 2 is again 6. Now the equation has become an equation in one variable, that is t. Now it's easy for us to simplify this equation and find the value of t. Let's simplify that. We have to take the LCM here. Now the LCM becomes 6. So it becomes 2 into 3 plus t plus 3 into t divided by 6 equals to 6. Now let's solve this. That is 6 plus 2t plus 3t becomes 6 into 6, 36. Now 6 plus 2t plus 3t is again 5t equals to 36. Now 5t becomes 36 minus 6, that is 30, and t becomes 30 by 5, that is 6. So the value of t we got here is 6. Now what's the next step? We are going to substitute the value of t in equation A. That is substituting t is equal to 6 in equation A. Now equation A is s is equal to 3 plus t. That is s is equal to 3 plus t is 6 that we found out here, and now s becomes 3 plus 6, that is 9. So the value we got for s is 9 and the value we got for t is 6. So st is our solution, and st is nothing but s is 9 and t is 6. Now let's verify whether this is a solution for this pair. Now for that, starting with the LHS, first equation, s minus t, that is 9 minus 6. 9 minus 6 is nothing but 3, yes, which is our RHS here. Now let's move on to the next equation. Starting with LHS, we have s by 3, that is 9 by 3, okay, plus t by 2, that is 6 here, that is 6 by 2, okay, equals to 9 by 3 is nothing but 3 and 6 by 2 is nothing but 3. Now 3 plus 3 is 6 and that's our RHS. So the verification part is also over, because 9, 6 is the solution for both of these equations, and that's the solution for this pair of linear equations in two variables. Now this is our next example. 3x minus y is equal to 3 and 9x minus 3y equals to 9. Now let this be our equation number 1 and let this be our equation number 2. Let's start with equation number 1, that is 3x minus y equals to 3. I am going to find the value of any variable in terms of other. Seeing this, it is clear that finding y is easy for us. That is, y is nothing but 3x minus 3. Now I am going to name this as equation number A. Please remember that finding the value of x in terms of y or y in terms of x is also possible. You can find either x in terms of y or y in terms of x. Both of them are true. Now here I found y in terms of x. Now let's move on. I am going to substitute yes, equation number A in equation number 2. We started with equation number 1, so we are going to substitute the value of A in equation number 2 only. Now substituting the value of A in equation number 2, then equation number 2 becomes what? 9 into x. Okay, 9x becomes like that, and minus 3 into y, and we have found out that y is 3x minus 3, that is 3x minus 3 is equal to 9. Now we are going to solve this. That is 9x minus 3 into 3x is nothing but 9x minus 3 into 3 is nothing, minus 3 into minus 3 is nothing but plus 9 equals to 9. So 9x and minus 9x becomes cancelled. We get 0 plus 9 equals to 9. That is 9 equals to 9. What is it? The x has eliminated here and we got 9 equal to 9. We know that 9 equal to 9 is true, but here the variable x is getting eliminated. In the previous examples, the values were not getting eliminated. Then if the value of x was found out, we were going to substitute that in here and find the other variable, that is y. But here the value of x is eliminated here, which means that this pair of linear equation have infinitely many solutions. If either of the variable gets eliminated while solving in substitution method, we must conclude that the equation has infinitely many solutions. What is the geometrical representation for infinitely many solutions? We know that it is the lines are parallel. So the lines will coincide, which means the one line is upon the other, which means these points of intersections are the solutions, which means it has infinitely many solutions. So remember one thing, while doing the substitution method, if either of the variable gets cancelled while substituting one in other, it means that the equations have infinitely many solutions. Now let's move on to another example. Now the next question is 0.2x plus 0.3y equals to 1.3 and 0.4x plus 0.5y is equal to 2.3. Note that here the coefficients are decimals. Now for our simplicity, I am going to multiply both of these equations throughout by 10 so that the decimal gets eliminated and we will get the whole numbers as the coefficients. Now multiplying this equation into 10 and this equation also into 10, we will get first equation as 2x plus 0.3 into 10 is 3y equals to 1.3 into 10 is nothing but 13. So this is our equation number 1. Now 0.4 into 10 gets 4x plus 0.5 into 10 becomes 5y equals to 2.3 into 10 becomes 23. So these are our two equations to be solved. Now I am going to consider equation number 1 and find the value of x in terms of y. That is 2x plus 3y equals to 13, which means 2x is nothing but 13 minus 3y and x is 13 minus 3y divided by 2. So this is our equation number A. Now I am going to substitute the value of x in equation number 2. That is substituting A in equation number 2. Equation number 2 becomes 4 into x. X is nothing but 13 minus 3y divided by 2 and plus 5y, that is 5 into y equals to 23. So this is our equation. Now we are going to simplify this, that is 4 divided by is 2. Now multiplying towards the brackets, that means 2 into 13 is 26 minus 2 into 3 is 6y plus 5y equals to 23. So 26 minus 6 plus 5, that is minus y equals to 23. So y becomes 26 minus 23, that is 3. So the value of y we got here is 3. Now we are going to substitute y is equal to 3 in equation number A so that we will get x. That is x is equal to 13 minus 3y. 13 minus 3y. Y is nothing but 3 divided by 2. Okay, 13 minus 3 into 3 is 9. Now divided by 2. Now 13 minus 9 is nothing but 4. That is 4 by 2 is again 2. So we got the solution. X is equal to 2 and y is equal to 3. That is 2, 3 is our solution. That is 2, 3 is our xy. So let's go for the verification part. Starting with the LHS. We can start with these two equations are converted into these two equations. Both of these equations are equal because we have multiplied both the equations throughout by 10. So there is no change in the equation. Now let's find out the LHS, that is 2 into x. X is nothing but 2. Yes. Plus 3 into y. Y is nothing but 3. Now simplifying 2 into 2, 4. 4 plus 3 into 3, 9. And 4 plus 9 is nothing but 13. That is our RHS. So first equation is verified. Moving on to the second, LHS becomes now 4x. 4 into x is nothing but 2 plus 5 into y. Y is nothing but 3. Now 4 into 2 is 8 plus 5 into 3 is 15 and 15 plus 8 is nothing but 23. Now which is our RHS. So verification part 2 is over. Now that's it. That was this question. For our simplicity, first we have multiplied throughout with 10 and back to the normal steps of substitution method. Next we will move on to another question. And the question is root 2x plus root 3y equals to 0 and root 3x minus root 8y equals to 0. Now let this be our equation number 1 and this be our equation number 2. Now for a change, let's take equation number 2 and find x in terms of y. From 2 we have root 3x is equal to root 8y. Now from here x is equal to root 8y divided by root 3. And now this is our equation number A. Now as usual we have to substitute A. not in 2 but in 1, because from 2 only we have expressed x in terms of y. So we have to substitute a in 1 now. Yes, substitute a in equation number 1. Now root 2 x, that is x is root 8y divided by root 3 and plus root 3y, and root 3y equals to 0. Now we have root 2 into root 8 is nothing but root 16y divided by root 3 plus root 3y equals to 0. From here we have root 16y plus root 3 into root 3 is 3y equals to 0. We can take y common here. Now y into root 16 plus 3 equals to 0. Now which implies we know that this is a product and that product is equal to 0, which means either this equals to 0 or this equals to 0. Since root 16 plus 3 cannot be 0, we can say that y is 0. So we got y as 0. Now we have to substitute y is equal to 0 in equation number 2. Now substitute y equals to 0 in our equation number 2 or in equation number A. Let's put in equation number A. Now x is equal to root 8 into y, that is 0 divided by root 3, and that is again 0. So we got x is equal to 0 and y is equal to 0, which means our solution is 0, 0. Let's go for the verification part. Starting from the LHS of the first equation, we have root 2 into x is 0 plus root 3 into y is 0, which means 0, which is our RHS. Now going to the second equation, that is LHS is root 3 into x, that is root 3 into 0 minus root 8 into y, that is root 8 into 0 equals to 0 minus 0 is again 0, which is our RHS. So the solution for this particular pair of linear equations in two variables is 0, 0, and we have found it using the substitution method. Now we shall move to the next question. Now the next question is 3x by 2 minus 5y by 3 is equal to minus 2 and x by 3 plus y by 2 equals to 13 by 6. Now let's simplify these equations, and the first equation becomes, we know 6 is the LCM here of the denominators, so it will become 3x into 3 minus 5y into 2 whole divided by 6 equals to minus 2, and 3x into 3 is 9x minus 5y into 2 is 10y, and this 6 goes to here with multiplication, that is minus 2 into minus 2 into 6, that is minus 12. So this is our first equation. Now the second equation, here also the LCM is 6, so it becomes 2x plus 3y by 6 equals to 13 by 6, which means 2x plus 3y equals to 13 by 6 into 6, which is again 13, that is 2x plus 3y equals to 13 is our second equation. Now we are going to apply the substitution method. We got two equations, and first of all we have to find x in terms of y or y in terms of x from any of these equations. Let us consider equation 1 first. From this we can find x, that is 9x becomes 10y minus 12 and x becomes 10y minus 12 divided by 9. So this is our equation number A. Now what we have to do is substitute this A in equation number 2. Substituting A in equation number 2, which means A is x is equal to 10y minus 12 by 9. Therefore 2 into x becomes 10y minus 12 divided by 9, okay, plus 3y equals to 13. Now let's simplify this, that is 20y minus 24 plus 3 into 9 is again 27y equals to 9 into 13, and 9 into 13 is 170. Now that's it. Now we have 20 plus 27 is 47y equals to 117 plus 24, that is, we have 141. Now y is equal to 141 divided by 47, and that is 3. So we got y as 3. Now we want to substitute y in equation number A. That y is 3. Now x becomes 10 into 3 minus 12 divided by 9, and 10 into 3 is 30, that is 30 minus 12 divided by 9. 30 minus 12 is 18, 18 by 9 is 2. So we got y is equal to 3 and x is equal to 2. That is 2, 3. 2, 3 is the solution. Let's go for verification. So this is our equation number 1, or we can choose this. Let us choose this. Therefore 9 into x, that is x is 2, starting with LHS. Now 9 into 2 minus 10 into y is 3. Now it will become 9 into 2 is 18 minus 10 into 3 is nothing but 30, and now it will become minus 12, which is our RHS. So that equation is verified. Now we will verify equation number 2, that is 2 into x, x is 2, plus 3 into y, 3 is 5, sorry, y is 3, and again this was our LHS. So 2 into 2 4, 4 plus 3 into 3 9, and 9 plus 4 is nothing but 13, which was our RHS. So that's it. The verification part is also over. So the solution for this particular pair of linear equations in two variables is 2, 3. Now let's move on to another question. Now the question is, solve 2x plus 3y is equal to 11 and 2x minus 4y equals to minus 24, and hence find m for which y is equal to mx plus c. First of all, we have to solve for this pair of linear equations. Then we will get a value for x and a value for y, and we will substitute those values in this equation and hence find m. That's our question in totality. Now let's move on and find each of the solutions one by one. Now consider 2x plus 3y equals to 11 as our equation number 1, and 2x minus 4y equals to minus 24 as our equation number 2. Using substitution method, we are going to solve this pair of linear equations, and now we have to find x in terms of y from any of these equations. Let's consider equation number 1, and from that we can find x, that is x is 2x is equal to 11 minus 3y, and x is nothing but 11 minus 3y whole divided by 2. So this is our equation number A. Now what we are going to do is substituting this x value, that is equation number A, in our equation number 2, because here we started with equation number 1 only. So we have to substitute the x value in equation number 2. Now 2 into x is nothing but 11 minus 3y whole divided by 2, okay, minus 4y equals to minus 24. Now 2 and 2 gets cancelled. Now 11 minus 3y minus 4y, minus 3y minus 4y is nothing but minus 7y equals to minus 24. Therefore 7y becomes, from here we know that 7y becomes 11 plus 24, and that is nothing but 35. Therefore y becomes 35 by 7, that is 5. So we got y is equal to 5 from this. Now the next step is substituting this value of y in our equation number A. That is substituting y is equal to 5 in equation number A. Equation number A is x is equal to 11 minus 3y. 11 minus 3 into y is nothing but 5. So we have substituted that, and by 2, which is 11 minus 3 into 5 is 15 divided by 2. 2, and we know that 11 minus 15 is minus 4. Minus 4 by 2 is again minus 2. So we got x is equal to minus 2. So the solution we got is x is equal to minus 2 and y is equal to 5. That is, this point is the solution for this pair of linear equation. Now we have to check whether this is, now we are going for the verification part. Let's do that. LHS is nothing but 2x plus 3y, that is 2 into minus 2 plus 3 into 5, and that is minus 4 plus 15 is again 11, which is our RHS. So verification part for first equation is over. Now verify for the second equation. LHS is nothing but 2 into x, x is minus 2, minus 4 into y, y is 5, and 2 into minus 2 becomes minus 4, minus 4 into 20 becomes minus 20, and minus 4 minus 20 is minus 24, which is our RHS. So the verification part is over. We got x as minus 2 and y as 5. Now we have solved the equation, so this part is over. Solve 2x plus 3y minus 11 and 2x minus 4y minus 24 is over. We have found that x is equal to minus 2 and y is equal to 5. Now we are going to find out m. Hence find m for which y is equal to mx plus c. That is, it is given that y is equal to mx plus c. Whatever it is given is given that y is equal to mx plus c, and we know the value for y and x, hence we want to find the value for m. Now y is nothing but 5 and m is nothing, we don't know, m into x is nothing but minus 2 plus c. So it will become like this, 5 is equal to minus 2m plus c. Therefore 2m is c minus 5 and m is c minus 5 divided by 2. So we have found out the value for m also, and that's the question. First we solve for this pair of linear equations, and from the given condition we have found out the value of m. Now we shall move to another question. The question is, the larger of two supplementary angles exceeds the smaller by 80 degree. Now find the angles. Since the angles are unknown to us, let's take the angles as two variables. Now let x and y be the angles. Now it is given that the angles are supplementary, and we know that the sum of supplementary angles is always 180 degree. So which means x plus y will be 180 degree, since it is given that the angles are supplementary. So this will become our equation number 1. Now the next condition given is, the larger of two supplementary angles exceeds the smaller by 18 degree. If x is the larger one, then x will be 18 degree more than the smaller one. That is, if y is the smaller, then y plus 18 is the x. So x is equal to y plus 18 degree is our second condition. So we got two conditions regarding these angles, and these two equations form a pair of linear equations in two variables, and solving these two equations we will get the angles. Now let's move on to the substitution method for solving this. From this, already from equation 2 x is found out, so we can directly substitute equation number 2 in equation number 1, since equation number 2 is already given as the value of x. Substituting equation number 2 in equation number 1, we will get x as x plus y, therefore x becomes y plus 18, and now plus y equals to 180 degree. Now y plus y is 2y, 2y plus 18 equals to 180 degree. Now 2y is 180 minus 18, that is 162. Now y becomes 162 divided by 2, that is 81 degree. So y we got as 81 degree. Now substituting this y value in equation number 2, we will get the value of x. That is, substituting y is equal to 81 in equation number 2, we will get the value of x. That is, x is equal to y plus 18, that is 81 plus 18 and that is 99. So this is the x value, that is x is equal to 99 degree and y is equal to 81 degree. So we will go for the verification part. Verifying equation number 1, LHS becomes x plus y and that is x is 99 degree plus y is 81 degree and that is 180 degree, which is our RHS. Now going to the second equation, x is equal to y plus 18. LHS is nothing but x, that is 99, and RHS is y plus 18. Let's go for RHS, y plus 18. Y is nothing but 81. 81 plus 18 is 99. So LHS becomes equal to RHS. So it is clear that x is equal to 99 degree and y is equal to 81 degree is the solution for this pair of linear equations. So the angles are 81 degree and 99 degree. Now let's move to the another question. And the question is, the coach of a cricket team buys 7 bats and 6 balls for rupees 3,800. Later she buys 3 bats and 5 balls for rupees 1,750. Find the cost of each bat and each ball. We are asked to find out the cost of a bat and that of a ball. Here the unknown quantities are cost of a bat and cost of a ball. So we can take some variables to represent the cost of bat and balls. So let x be the cost of a bat and y be the cost of a ball. Now let's look into the conditions. The coach of a cricket team buys 7 bats and 6 balls. A bat costs x rupees, so 7 bats will cost 7x rupees and 6 balls will cost 6y rupees, and together 7 bats and 6 balls cost rupees 3,800. Therefore 7x plus 6y becomes 3,800. So this is our first condition. Now again, later she buys 3 bats and 5 balls. 3 bats will cost 3x rupees and 5 balls will cost 5y rupees, and together they will cost 3x plus 5y, that is 1,750. It is given in the question. So these are the two conditions given in the questions. Solving these two linear equations in two variables, we can find the value of x and y. Hence we will get the cost of a bat and cost of a ball. Now let's move on to solve these two equations. For that, first of all, from 1 we can find the value of x, that is 7x become 3,800 minus 6y, and x becomes 3,800 minus 6y divided by 7. Now this is our equation number A. Now we are going to substitute equation number A in equation number 2, that is substituting A in 2. Here we have 3x, that is 3 into 3,800 minus 6y whole divided by 7 plus 5y equals to 1,750. Now we have to simplify this LHS. For that, first of all, we can take the LCM like this, that is 3 into 3,800 minus 6y plus 7 into 5 is 35y whole divided by 7 becomes 1,750. First of all, we took the LCM, that is 7. So in order to make denominator 7 here, we multiplied this term by 7, that is 35y, and this term remains the same. Now what is 3,800 into 3? That is 38 into 3. 8 3s are 24 and 3 3s are 9, and 9 plus 2 is 10. 9 plus 2 is 11. That is 11,400. 11,400 minus 6 into 3 is 18 minus 18y plus 35y becomes 1750 into 7. Therefore 175 into 7, that is 35, 3, 49 plus 3 is 52. Now 12,250. Now 8 minus 18y plus 35y is nothing but 17y, and it will become 12,250. This term will go here and will get a subtracted, that is 11,400. Now 12,250 we will do here. 12,250 minus 11,400. 5, 8, 850 divided by 17, and that is, we know it's 50. So we got y as 50. Now we have to solve for x, that is substituting this y value in equation number A. That is, we are going to substitute that. For that, we have x is equal to 3,800. X is equal to 3,800 minus 6 into y. That is, we have y is equal to 50 by 7. Now 3,800 minus 6 into 50 is 6 5s are 30, and it is 300 divided by 7. 3,800 minus 300 is 3,500 divided by 7, that is 500. So we got x is equal to 50 and y is equal to, x is equal to 500 and y is equal to 50. We will go for verification part, and the verification is like this. We can take the LHS. LHS is 7 into x, that is 7 into x is 500, okay, plus 6 into y is 50. So that will become 7 5s are 35. So 3,500 plus 300 is 3,800, which is our RHS. So that part is over. Now checking this one, 3 into x is 500 plus 5 into y is 50. 3 into 500 is 1,500 plus 5 into 50 is 250, and we will get 1,750 as the sum, which is our RHS. So hence the verification part is over. So we got x is equal to 500 and y is equal to 50. That is, x was the cost of a bat. So the cost of a bat is 500 rupees and the cost of a ball is 50 rupees. So that's the answer. We can move on to the next question. And the question is, the taxi charges in a city consist of a fixed charge together with the charge for a distance covered. Always the taxi fare have a fixed charge, and to that fixed charge, the charge for distance cover, each distance covered is added. That is, charge for distance covered is added. The taxi charge pattern is like this. First of all, there is a fixed charge for all trips, and again to the fixed charge, the charge for the distance covered is added. Now moving on, for a distance of 10 km, the charge paid is rupees 105. For 10 km, one have to pay rupees 105. And again, the charge for the charge for 15 kilometers, one have to pay rupees 155. So these are the data given in the question, and we are asked to find the fixed charges and the charge per kilometer. Always a fixed charge is added to the charge per kilometers, and hence we can find the total charge. And it is given that for 10 kilometers the total charge is 105, and for 15 kilometers the total charge is rupees 155. Here the unknowns are the fixed charges and the charge per kilometer. So let x be the fixed charge and y be the charge per kilometer. Now for 10 kilometers we have to pay rupees 105. So 105 will be always the fixed charge for distance covered or charge per kilometer. So the fixed charge is always x rupees, and again the charge for the distance covered will be the charge for distance of 10 kilometers. That is, for each kilometers we have to pay y rupees. For 10 kilometers we have to pay 10y rupees. So x plus 10y will become rupees 105. Here also for 15 kilometers one have to pay rupees 155. Here there will be a fixed charge, that is x, and for 15 kilometers we have to pay the charge per kilometers, that is y rupees per kilometer. That is, for 15 kilometer we have to pay 15y rupees. So together x and 15y will become rupees 155. So from these two conditions we will get two equations, that is x plus 10y equal to 105 and x plus 15y equal to 155. These are our two equations, and solving this pair of linear equations in two variables we will get the values for x and y. Moving on, we have to find x from equation 1, that is x is equal to 105 minus 10y. This is our equation number A. Now we are going to substitute this value of x in equation number 2, that is substituting A in equation number 2. Substituting A, we will get x is nothing but 105 minus 10y. So 105 minus 10y plus 15y, okay, will be 155. Simplifying, we get 105 minus 10y plus 15y is plus 5y, which is equal to 155. Now we will get 5y equals to 155 minus 105, that is 155 minus 105, which is equals to 50. Therefore y is nothing but 50 by 5, that is 50 by 5 is nothing but 10. So we got y as 10 rupees. Now in order to find x, we have to substitute this y value in equation number A. Substituting y is equal to 10 in equation number A. That is, x is equal to 105 minus 10y. That is 105 minus 10 into y is nothing but 10, which means 105 minus 100, which is 5 rupees. So we got x is equal to 5 rupees and y is equal to 10 rupees, which means the fixed charge is rupees 5 and the charge per kilometer is rupees 10. So we got two such values. Now we have to find the how much does a person have to pay for traveling a distance of rupees 25 kilometers. How much one have to pay for traveling rupees 20 for traveling 25 kilometers. It will be for 25 kilometers. We will always have a fixed charge, that is x. Yes, and for 25 kilometers we have to pay y rupees per kilometers. For 25 kilometers it will be 25y. So for 25 kilometers one have to pay the fixed charge x rupees and again rupees y per kilometer. So for 25 kilometers it will be 25y. So x plus 25 is the 25y will be the charge for 25 kilometers. Also we know that x is equal to 5 rupees and y is equal to 10 rupees. So we have 5 plus, this will be equal to 5 plus 25 into y is 10. So 5 plus 250, that is rupees 255. So we got the fixed charge as 5 rupees, the charge per kilometers as 10 rupees, and now finally we found that for 25 kilometers one have to pay rupees 255. So that is the question. Now we shall move to another question. The question is, a fraction becomes 9 by 11 if 2 is added to both numerator and denominator. If 3 is added to both numerator and denominator, the fraction becomes 5 by 6. Find the fraction. We are asked to find the fraction. So to find a fraction, we always need the numerator part and the denominator part, and both the numerator and denominator are unknown to us in this question. So let's take that x be the numerator and y be the denominator. And now we will check for the conditions. A fraction becomes 9 by 11 if 2 is added to both numerators and denominators. So it is given that x plus 2 by y plus 2. That is 2 is added to numerator and 2 is added to denominator. Then we will get the fraction like 9 by 11. So this is our first condition. And again we have, if 3 is added to both numerator and denominator, the fraction becomes 5 by 6. That is, 3 is added to numerator and 3 is added to denominator, then we will get 5 by 6. So we got two equations like this, and this is a pair of linear equations in two variable, and we have to solve this. We can solve this. We will get 11x. Cross multiplying this, we will get 11x plus 22 equals to 9y plus 18. That is 11x minus 9y will become 18 minus 22, that is minus 4. That is 11x minus 9y equals to minus 4 is our first equation. And here we have cross multiplying, we will get 6x plus 18 equals to 5y plus 15. So that will become 6x minus 5y equals to 15 minus 18, and we know that 15 minus 18 is minus 3. So 6x minus 5y equals to minus 3 is our second equation. Now we have to solve these two equations by substitution method. Now for that we can find the value of x from equation 1, that is 11x minus 9y equals to minus 4, which means 11x is equal to minus 4 plus 9y, and x is equal to 9y minus 4 divided by 11. Now this is our equation number A, and now we are going to substitute this x value in equation number 2, that is substituting equation number A in equation number 2. Now equation number 2 will become like this: 6 into x, that is 6 into 9y minus 4 by 11 minus 5y equals to minus 3. Solving this, taking LCM, we will get 6 into 9y minus 4 minus 55y, and this 11 which is divided here will get multiplied in the RHS, that is minus 33 will become the right hand side. So simplifying this, we will get 50, opening the brackets, 54y minus 24 minus 55y equals to minus 33. Solving 54y minus 55y, we will get minus y equals to minus 33, and 24 which is subtracted here will become added here, so it will become minus 33 plus 24. Therefore minus y becomes minus 33 plus 24, that is minus 9, and we have y is equal to 9. So we got y is equal to 9. Now we are going to substitute this value of y in equation number A, and hence we will get the value of x. So x is nothing but x is equal to 9 into y, that is 9 into 9 minus 4 divided by 11, that is 9 9s are 81 minus 4 divided by 11, that is 81 minus 4 is 77, 77 by 11 is nothing but 7. So we got x is equal to 7 and y is equal to 9. So the numerator is nothing but 7 and denominator is 11. So our fraction will become, required fraction is 7 by 9. So that's the answer to this question. Now we will move on to another question. Question is, 5 years hence the age of Jacob will be 3 times that of his son, and 5 years ago Jacob's age was 7 times that of his son. What are their present ages? We are asked to find the present age of Jacob and his son. So we will take x as present age of Jacob and y as present age of his son. And in the question, the question gives like this: 5 years hence, the age of Jacob will be 3 times that of his sons. That is, after 5 years, the relation between the age of Jacob and his son is that Jacob will be 3 times that of his son. So, for solving this question easily, we can do a table like this. Let x be the present age of Jacob and y be the present age of his son. So the present age of Jacob is x and the present age of his son is y. After 5 years, that is 5 years hence means after 5 years, we know that obviously Jacob's age will become x plus 5 and son's age will become y plus 5. And in the question it is given that the age of Jacob, 5 years hence the age of Jacob will be 3 times that of his son. We know that after 5 years Jacob's age will be x plus 5 and the son's age will be y plus 5, and in the question it is given that Jacob's age is, that is x plus 5 is 3 times that of his son, that is 3 times y plus 5. So this is the first condition given in our question. So simplifying this, we will get like this: x plus 5 is equal to 3y plus 15, which means x minus 3y will become 10. So this is our simplified form of equation number 1. Now again it is given that 5 years ago Jacob's age was 7 times that of his son. That is, before 5 years. Before 5 years, what will happen to the age of Jacob and his son? Their present age is x. Therefore, before 5 years, their age was Jacob's age was x minus 5 and the son's age was y minus 5. So, before 5 years ago, Jacob's age, and in the question it is given that Jacob's age was 7 times that of his son. That is, Jacob's age, that is x minus 5 was 7 times that of his son. That is 7 times y minus 5. This is the second condition given in the question. That is, x minus 5 becomes 7y minus 35, and that is x minus 7y equals to minus 35 plus 5, which is minus 30. So x minus 7y equals to minus 30 is our equation number 2. Solving these two equations, we will get the present ages of Jacob and his son. So considering equation number 1, and we are going to find the value of x from equation number 1. That is, x is equal to 10 plus 3y. This is our equation number A. Now we are going to substitute this x value, that is equation number A, in equation number 2. Substituting A in equation number 2, we will get x minus 7y. We know that x is 10 plus 3y minus 7y equals to minus 30. So we will get like this: 10y plus 3y minus 7y is nothing but minus 4y equals to minus 30. So minus 4y will become minus 30 plus 10. Sorry, 10 is added here. So minus 30 minus 10. So minus 4y is minus 40, which means y becomes minus 40 by minus 4, which is equal to 10. So y is equal to 10. Now to find x, we have to substitute this y value in A. That is, x is 10 plus 3y. That is 10 plus 3 into y is 10. So 10 plus 30, which is equal to 40. So we got x is equal to 40 and y is equal to 10. So x is the present age of Jacob and that is 40 years, and y is the present age of his son, that is 10 years. So we got the answer like this. So in all these questions we solved the pair of linear equations we got by substitution method. In the next class we will learn another method to solve a pair of linear equations in two variables, that is elimination method. Till then, wait for the next video. Stay tuned.